Okay, so we want to build an amplifier. You see an amplifier using a BJT. So let's get rid of this. And so we want to do an amplifier. So if we go over here and look at general amplifiers, you see in order to make an amplifier, we need some type of dependent source, which takes our input and amplifies it over. Now the BJT, as long as you're in active, let's go and look at that. So if I come over here and look at a general BJT. So here is the symbol for my BJT. And so it has a base, a collector, and an emitter terminal. And if it's inactive, it has this model. So this is my IB, and this is my amplified IB. This is my collector, this is my emitter, and this is my base. So what you see is that we get a dependent source, which is dependent on the current. So this is the configuration that we have, which is a current controlled current source. So this should work as an amplifier. Now we want to take and we want to change this current into a voltage, so we're going to have to put a resistor over here, and we're also going to need a power supply in order to get it to work, and we want our input connected over to this sensing part, or this IB terminal. So let's see what this looks like. So here is our sinusoidal input, let's just call it Vin, and we want to connect that to the base of my transistor. And we're going to put my resistor, which we'll call RC because it's connected to the collector, and then we have our power supply right here, which is our 10 volts. So this is what our signal our circuit kind of looks like. Let's go over to LT-Spice, new schematic, get a component. We're going to grab an NPN transistor, and I'm going to right click on it and say pick new transistor. Well, here's the 2N3904. So if I scroll over, these are the parameters that it's using. So you see it's using an IS of 1e to the minus 14, a VA of 100, and a beta of 300. So you see that's the same thing that I have. So that is the 2N3904 transistor. So we're going to put a ground right here, put a resistor up here. We are going to go grab a voltage source. We're going to put one over here for my input and one up here for my power supply. So we connect in some grounds and then we wire it up. And then I just wire down here and it connects everything. Okay, so this is my 10 volt power supply. Let's just call it VDC. This is my VIN. And I right click on this, click on advanced, sign. And it has an amplitude of 2 volts peak to peak, which is a 1 volt peak and a 1 kilohertz frequency. We don't really know, so let's just pick 10 kilo ohms. This is connected to my collector, so we're going to call it RC. So now we move everything around. Okay, so now we want to do a transient simulation. So here we're going to click transient. It's 1 kilohertz, which has a period of 1 millisecond. So I'm going to do 5 milliseconds, so I should get 5 periods. Move this, we'll just throw it here in the middle somewhere. And then we run this. And let's go ahead and label our output. Right here. So, and let's go ahead and label our input. right over here. So you see, if I look at my input, it's a sinusoidal signal, but if I look at my output, it's either 10 volts or 0 volts. So it's not really an amplified sine wave. It's this weird looking square wave now. And so we have to figure out what is wrong. So let's go back and look at our operating regimes of our BJT. Okay, so we start with cut off. So in cut off, VBE is less than the turn on voltage. Let's just say less than 0 right now. And in this case, the transistor is an open circuit. Okay, and then we have active. And in active, VBE is greater than 0, and we want VCE to be greater than 0. So we're just going to say greater than, say, 0.5 volts. And in this case, it acts as a dependent source. And then we have saturation. And in this case, VBE is greater than 0, and VCE is less than, let's just say 0.5 volts. And then this is approximately a short circuit. Okay, so let's go back and look at what we have. So starting right here you see my input is -1. So the base, which is right here, to the emitter right here, my base to emitter voltage is less than 0. So this state right here is cutoff. So in cutoff, that's like there not being a transistor there, an open circuit, and you can see that there's no current flow and V out equals 10 volts. So this is cutoff condition here. Okay, so now if we put this back in here, now we're going to look at this case. Well, in this case, it's 1 volt. I'm above the threshold condition. So it's going to have some current. Well, if I go and look, if we remember, that if I look at my IC versus VBE, it acts as a diode, so it looks something like that. And this point here is about 0.7 volts. If I'm putting in 1 volt, you see it has a really high current. If it has a really high current, then I look at my VCE is equal to 10, which is my DC voltage, minus my resistor, which is 10,000 times my IC. So if my IC gets too large because I'm over here, you're going to see that this point here is going to get to be greater than 10, and so I'm in saturation. If I'm in saturation, coming back over here, you can see that that means that this acts as a short, so it basically looks like this. Oh, except for it won't let me short it. Okay. But then this voltage will be close to ground. So you see this is basically 0 volts. If I want to see what it exactly is, you see that it's 8 millivolts. So that's pretty close to 0. So in this configuration, I'm switching from cutoff to saturation, and I'm supposed to be in active. So I have to fix this so that it is no longer going from cutoff to saturation. So the first thing that I want to do is make sure that my input voltage is always greater than the 0 volts. So I'm going to come in here and grab another voltage source. And this is going from -1 to 1, so I'm going to create a 2 volt. Let's put in a 2 volt and call this VB for my bias. Okay, and then I'm going to move my ground down to the bottom and move this up here. Okay, now we also, coming back over here, is it would be easier to control if when this turns on, it's linear so that I can change this voltage a little bit and it doesn't have that exponential response. So I'm going to come in here and add a resistor in. Let's just put in a big resistor, 100 kilo ohms, so that I get a more gradual response. Okay, let's see what this looks like now. So my input voltage right here, you can see is going from 1 volts to 3 volts, so it's not going into cutoff. Now I come here and my output is still really weird because it's staying below like that 0.5 volts. So in this state, it's still in saturation. So this creates a current. You can see here's my base current. It's around 13 microamps and then it's oscillating. Okay. So what we're going to need to do is that's too much current once I amplify it. So I'm going to have to drop this resistance down. And now if I look at my voltage here, you see it doesn't get above up to 10 and it doesn't get below like the 0.5 volts. So now it's all inactive. So now if I look at my input and my output is now larger than my input, and I've created my first amplifier, and this is my solution. So let's go over here and draw it on our sheet so that we have our final answer. So this is what my final design looks like. I have a 10 volt supply, a 1 kilo ohm resistor. I have my BJT transistor. I ground my emitter. I put a resistor. Well, let's make this our sinusoidal voltage source, and this is our bias voltage. So this is 2 volts, and this is 1. And this is 100 kilo ohms. And ground this, and this is my answer. And I'm all done.